Hello guys, I hope you are doing well. Welcome back to another video where we are looking at differentiation, specifically implicit differentiation. Now, in what way is implicit differentiation involved here? Well, we want to think about how we're going to differentiate y equals x to the power of x. Now, in another series, we've seen how we differentiate 2 to the power of x, or a number to the power of x, a number that's not e. And to work out dy dx, well, what we would do is take the natural log of both sides. So we have natural log of y equals the natural log of x to the power of x. And why would we do this? Well, it means that we can now use our log laws, and it becomes this, x times ln of x, using that power law. Now we can differentiate both sides. Both sides can be differentiated with respect to x. So with the left-hand side, by applying implicit differentiation, we get ln of y, well, that's 1 over y, and then differentiating y with respect to x, so multiplied by the derivative of y with respect to x, which is dy dx. And then on the right-hand side, we have a product, so we let u equal x and v equal ln of x. Du by dx is equal to 1, and dv by dx is equal to 1 over x, because ln of x differentiates to 1 over x. And then the product rule is u times dv dx plus v times du dx. So we've got u times dv dx, so that's x times dv dx, which is 1 over x, plus v, which is ln of x, multiplied by du dx, which is 1. Simplifying, we get x times 1 over x, which is just 1, plus ln of x. So we end up with here 1 plus ln of x. Then getting dy dx by itself, we get that dy dx is equal to y lots of 1 plus ln of x. And y was equal to x to the power of x. So we can replace y with x to the power of x times 1 plus ln of x. And there we go. That's how we do this kind of question, guys. Let's have a look at another example where we have, let's make it a bit tougher. Let's go y equals sine of x to the power of cos of x. So again, looks complicated, but it's the same principle. So we want to work out dy dx, of course. We're trying to differentiate this. So ln of y equals ln of sine x to the power of cos x. And then again, using the log law, we get ln of y equals cos x times ln of sine x. And then we apply differentiation again. So differentiate both sides with respect to x. The left side is an implicit differentiation, so an implicit derivative. We get 1 over y because ln of something differentiates to 1 over that thing, multiplied by the derivative of the inside function, or the derivative of y, which is dy dx. The right-hand side is a product, so we have u equals cos of x, and we have v equals ln of sine x. Okay, and then we have du by dx equals minus sine x. And then we have v, or dv dx, should I say, and that's going to be a chain. So that's 1 over sine x multiplied by the derivative of sine x, which is cos x. Okay, so that simplifies to cos x over sine x. Now we could write this as 1 over tan x or even cot x, but I'm just going to leave it like this for now. Okay, so the product rule is u dv dx plus v du dx. So that becomes u, which is cos x, times dv dx, which is cos x over sine x, plus v, which is ln sine x, and then multiplied by du dx, which is minus sine x. Okay, then we can just simplify this. So this can simplify to cos squared x over sine x minus sine x ln of sine x. Looking very complicated, but really, when we look at it and we look at it given what we know, it's not really utilizing anything different, other than that initial step of taking ln's of both sides. But it's one of those things where when you're exposed to it, you get used to it. And if you're looking to get A's, A stars, higher grades, you want to be exposed to such questions. And that's what this is. So 1 over y dy dx is equal to cos squared x over sine x minus sine x times ln of sine x. Okay, and then dy dx is equal to y times all of this. But remember, y was equal to sine x to the power of cos x. I'm just going to write that in straight away. So rather than writing y times all of this, I'm going to write it as sine x to the power of cos x multiplied by cos squared x over sine x minus sine x ln of sine x. Okay, and this is our final answer. So let me just change the color. This here is our final answer for dy dx. So funky looking answer, but that is what it is. So now you know that when you have something to the power of something else, this taking ln's of both sides idea is something that you can apply. You might even wonder, would they ask me something like this in an exam? Well, they could, because as you've seen, it doesn't require any knowledge beyond what you know. And I think it's just good to have fun with the process of implicit differentiation and practicing other aspects of differentiation too. I mean, we practice the chain rule here, we practice the product rule as well. So it's good to get practice of all three. And also, you make connections between the three and you enjoy it more because you get it. So thank you guys for staying and watching this video. Hopefully you got a lot of value out of this. I will see you in the next one. Take care.